Okay, this problem is actually really cool, even though it sounds pretty boring. We have two billiard balls of the same mass going to hit each other. Now, we know that we're going to have conservation momentum. So first thing I'm going to write down is initial momentum equals final momentum. Then, because it says it's perfectly elastic, we also know our little special equation that comes from conservation momentum mixed with conservation of energy. We have V1 initial plus, minus V2 initial equals V2 final minus V1 final. All right, so now let's go back to conservation momentum. We have two equal size billiard balls going to hit each other. So we have mass 1 V1 initial plus mass 2 V2 initial equals mass 1 V1 final plus mass 2 V2 final. All right, the masses we know are the same. So that's really nice because we can see that there's an exact same mass in every single equation. And now, hopefully you're seeing something interesting, because we're going to have V1 initial plus V2 initial equals V1 final plus V2 final. And this looks really similar to this equation up here. These two equations, they look crazy similar. And this is going to bring in some like really weird coincidences. Okay, so let me do this again. V1 initial plus V2 initial equals V1 final plus V2 final. Also, I'll put this one in a different color. How about blue? V1 initial minus V2 initial equals V2 final minus V1 final. All right, so it tells us that in part A, remember, part A, the first ball is going at 1.5 meters per second and the second ball is not moving. Then it gives us some different initial conditions, but it's just these two equations. So what I'm going to do is I'm going to show you, after you answer their questions and you get their answers, which you can see in the back of the book, I want you to see why that keeps happening, why that coincidence keeps happening. So what I want to do is I want to solve for V2 initial in this equation, and I'm going to substitute it in for this one. All right, stay with me. So up here we have V2 initial equals V1 minus V1 initial plus V2. On the bottom one, we have, if I put it on the right side and move everything to the left side, V2 initial equals V1 minus V2 plus V1. Then, look at these two equations. I'm going to add them, because I see that this and this are going to cancel, and this and this are going to cancel, and I'm going to get 2V2 initial equals 2V1. So, because I know you can do this last step of math, every single time, no matter what, the initial velocity of the second ball is going to equal the final velocity of the first ball. And hopefully you see that in your answers for A, B, and C. That's pretty crazy. And then we're going to do the same thing, but we're going to solve for V1 initial this time. All right, we're going to solve for this one this time. So we have V1 initial equals V1 plus V2 minus V2 initial. Then the second equation, we have V1 initial equals V2 minus V1 plus V2 initial. Add them. we go, these two cancel, we get 2v1 initial equals 2v2, which again shows us that every single time, no matter what, the initial velocity of the first ball is going to equal the final velocity of the second ball. That's crazy. Make sure that happens in your answers. It works with the answers in the back of the book, with the answers that I got. Make sure it works with your answers and notice the crazy pattern.